Topic 1. Cable installation planning is the first subtopic in the second topic of the book Data, Voice, and Data Video Cabling, 3rd edition. It explains how to design a VDV cabling system based on the customer's needs, the building structure, and the industry standards. It also covers how to estimate the cost, time, and materials for the project. The cable installation planning process involves the following steps. Assessing the customer's needs. This step involves meeting with the customer and asking questions about their current and future VDV requirements, such as the number and type of devices, the location and layout of the rooms, the expected data rate and quality, and the budget and schedule constraints. Surveying the building structure. This step involves inspecting the building and taking measurements of the floor plan, ceiling height, wall thickness, existing cable pathways and supports, electrical outlets, grounding and bonding points. Environmental conditions and potential hazards. Selecting the cable type and category. This step involves choosing the appropriate cable type, such as twisted pair, coaxial, or fiber optic, and categories such as Cat5e, Cat6, RGSX, or OM3 for each VDV application, based on factors such as bandwidth, attenuation, impedance, crosstalk, noise, interference, distance, cost, and compatibility. Designing the cable layout. This step involves drawing a schematic diagram of the cable layout that shows the location and length of each cable run, the type and category of each cable segment, the termination points, such as jacks, patch panels, or connectors, the labeling scheme, and the cable pathways and supports, such as conduit, cable tray, raceway, J-hooks, or cable ties. Estimating the cost. This step involves calculating the total cost of the cable installation project by adding up the cost of labor, such as hourly rate, overtime pay, travel expenses, materials such as cables, connectors, jacks, patch panels, tools such as cable reels, fish tapes, cable strippers, testing equipment such as testers, and overhead such as permits, insurance. Estimating the time. This step involves estimating the total time required for the cable installation project by adding up the time for each task, such as planning, surveying, pulling, terminating. Taking into account factors such as crew size, skill level, availability of materials and tools, working conditions, and contingencies. Preparing a proposal. This step involves preparing a written proposal that summarizes the scope of work, design specifications, cost estimate, time estimate, warranty terms, payment terms, and contract terms for the cable installation project. The proposal should be clear, concise, accurate, and professional. Topic 2. Cable types and categories is the second subtopic in the second topic of the book Data, Voice, and Data Video Cabling, 3rd edition. It describes the different types of cables that are used for VDV applications, such as twisted pair, coaxial, and fiber optic cables. It also explains the different categories and ratings of these cables, such as Cat5e, Cat6, RG6, and OM3. The cable types and categories subtopic covers the following points. Twisted pair cables. These are cables that consist of 2 or more insulated copper wires twisted together to reduce electromagnetic interference, EMI, and crosstalk. Twisted pair cables can be classified into 2 types: unshielded twisted pair UTP and shielded twisted pair STP. UTP cables have no additional shielding around the wires, while STP cables have a metallic foil or braided shield around the wires or the cable. UTP cables are more common and cheaper than STP cables, but STP cables offer better protection from EMI and crosstalk. Coaxial cables. These are cables that consist of a single copper conductor surrounded by a layer of insulation, a metallic shield, and an outer jacket. Coaxial cables have a high bandwidth and can carry analog or digital signals over long distances with minimal loss or interference. Coaxial cables can be classified into two types, thinnet and thicknet. Thinnet cables have a diameter of 0.25 inches and are used for short-distance connections, while thicknet cables have a diameter of 0.5 inches and are used for long-distance connections. Fiber optic cables. These are cables that consist of one or more strands of glass or plastic fibers that transmit light signals instead of electrical signals. Fiber optic cables have a very high bandwidth and can carry digital signals over very long distances with minimal loss or interference. Fiber optic cables can be classified into two types, single-mode and multi-mode. Single-mode fibers have a small core diameter and can carry only one wavelength of light, while multi-mode fibers have a larger core diameter and can carry multiple wavelengths of light. The cable types and categories subtopic also covers the different standards and ratings that are used to specify the performance and quality of VDV cables, such as Category CAT. This is a rating system for twisted pair cables that indicates the maximum data rate, bandwidth, frequency, and attenuation that the cable can support. The higher the category number, the better the performance and quality of the cable. The most common categories for VDV applications are Cat5e, Cat6, Cat6a, Cat7, and Cat8. Radio grade RG. This is a rating system for coaxial cables that indicates the impedance, attenuation, capacitance, and shielding of the cable. The lower the RG number, the thicker and better the performance and quality of the cable. The most common RG ratings for VDV applications are RG6, RG11, RG58, RG59, and RG62. Optical mode ohm. This is a rating system for multi-mode fiber optic cables that indicates the bandwidth, distance, core diameter, cladding diameter, and numerical aperture of the cable. The higher the ohm number, the better the performance and quality of the cable. The most common ohm ratings for VDV applications are ohm1, ohm2, ohm3, ohm4, and ohm5. Topic 3. Cable pathways and supports is the third subtopic in the second topic of the book Data, Voice, and Data Video Cabling, 3rd edition. It discusses how to install the cable pathways and supports that are used to route and secure the cables in a building. It includes topics such as conduit, cable tray, raceway, J-hooks, and cable ties. The cable pathways and support subtopic covers the following points. Conduit. This is a rigid or flexible metal or plastic tube that encloses and protects the cables from physical damage, moisture, fire, and a first. Conduit can be classified into two types, electrical metallic tubing, EMT, and electrical non-metallic tubing, ENT. EMT is made of steel or aluminum and is suitable for indoor or outdoor use, while ENT is made of PVC and is suitable for indoor use only. Conduit can be installed using various fittings, such as couplings, elbows, connectors, and boxes. Cable tray. This is a metal or plastic structure that supports and organizes the cables in a horizontal or vertical direction. Cable tray can be classified into four types: ladder, solid bottom, trough, and wire mesh. Ladder cable tray has rungs that support the cables. Solid bottom cable tray has a flat surface that supports the cables. Trough cable tray has a U-shaped channel that contains the cables. And wire mesh cable tray has a grid-like structure that supports the cables. Cable tray can be installed using various accessories, such as clamps, brackets, splice plates, and covers. Raceway. This is a metal or plastic channel that conceals and protects the cables on walls, ceilings, or floors. Raceway can be classified into two types, surface raceway and underfloor raceway. Surface raceway is mounted on the surface of walls or ceilings and has removable covers that allow access to the cables. While underfloor raceway is installed below the floor level and has access points that allow access to the cables. Raceway can be installed using various components, such as junction boxes, fittings, outlets, and devices. J-hooks. These are metal or plastic hooks that suspend and support the cables from ceilings, walls, or beams. J-hooks can be classified into two types: standard J-hooks and batwing hooks. Standard J-hooks have a loop-shaped design that holds the cables, while batwing hooks have a wing-shaped design that attaches to various structures. J-hooks can be installed using various methods, such as screws, nails, clips, or straps. Cable ties. These are plastic or nylon straps that bundle and secure the cables together. Cable ties can be classified into two types: reusable cable ties and disposable cable ties. Reusable cable ties have a hook and loop mechanism that allows them to be opened and closed repeatedly, while disposable cable ties have a locking mechanism that allows them to be closed once and cut off when needed. Cable ties can be installed using various tools, such as scissors, pliers, or tensioning tools. Topic 4. Cable pulling and termination is the fourth subtopic in the second topic of the book Data, Voice, and Data Video Cabling, 3rd edition. It covers how to pull and terminate the cables at both ends using the proper tools and techniques. It includes topics such as cable reels, fish tapes, cable strippers, crimpers, punch-down tools, connectors, jacks, and patch panels. The cable pulling and termination subtopic covers the following points. Cable pulling. This is the process of pulling the cables from the cable reel to the termination point along the cable pathway. Cable pulling involves the following steps. Preparing the cable reel. This step involves placing the cable reel on a stand or a jack. That allows it to rotate freely and applying a brake or a tension device to control the speed and force of the cable pulling. Preparing the fish tape. This step involves inserting a fish tape, a flexible metal or fiberglass rod, into the conduit, raceway, or ceiling space that will guide the cable to the termination point. The fish tape should have a hook or an eyelet at the end that can attach to the cable. Attaching the cable to the fish tape. This step involves stripping a few inches of the outer jacket of the cable and attaching it to the hook or eyelet of the fish tape using electrical tape or a pulling grip. The cable should be aligned with the fish tape and secured tightly to prevent slippage or damage. Pulling the cable. This step involves pulling the cable along with the fish tape from one end to the other using a steady and smooth motion. The cable should be pulled with care to avoid kinks, twists, bends, knots, or snags that can damage or weaken the cable. The cable should also be pulled with enough slack to allow for termination and testing. Cable termination. This is the process of connecting the cables to the devices or equipment at both ends using various tools and techniques. Cable termination involves the following steps. Stripping the cable. This step involves removing a portion of the outer jacket and insulation of the cable to expose the conductors or fibers using a cable stripper or a knife. The stripping length and depth should be appropriate for the type and category of the cable and the connector or jack that will be used. Crimping or punching down the cable. This step involves attaching a connector or a jack to the end of the cable using a crimper or a punch-down tool. A crimper is a tool that squeezes or compresses a connector around the conductors or fibers of the cable, while a punch-down tool is a tool that inserts or pushes down the conductors or fibers into slots or terminals of a jack. The crimping or punching down should be done with care to ensure a secure and reliable connection. Installing the connector or jack. This step involves installing the connector or jack into a device or equipment such as a patch panel, an outlet, a wall plate, or a network interface card. The installation should be done with care to ensure proper alignment and orientation of the connector or jack. Topic 5. Cable testing and troubleshooting is the fifth subtopic in the second topic of the book Data, Voice, and Data Video Cabling, 3rd edition. It explains how to test and troubleshoot the cables using various instruments and methods. It includes topics such as continuity testers, wire mappers, cable testers, tone generators and probes, and TDRs. The cable testing and troubleshooting subtopic covers the following points. Continuity testers. These are simple devices that check if there is a complete electrical path between 2 points of a cable. Continuity testers have a battery, a light, and 2 probes that are connected to the ends of the cable. If the light turns on, it means that the cable has continuity. If the light does not turn on, it means that the cable has an open or a short circuit. Wire mappers. These are devices that verify if the wires of a cable are connected correctly to the pins of a connector or a jack. Wire mappers have a main unit and a remote unit that are plugged into the ends of the cable. The main unit sends a signal to the remote unit and displays the wiring configuration of the cable. If the wiring configuration matches the standard or the specification, it means that the cable is wired correctly. If the wiring configuration does not match, it means that the cable has a miswire, a reversal, or a split pair. Cable testers. These are devices that measure the performance and quality of a cable based on various parameters, such as length, resistance, capacitance, impedance, attenuation, crosstalk, noise, and bandwidth. Cable testers have a main unit and a remote unit that are plugged into the ends of the cable. The main unit sends a signal to the remote unit and displays the test results of the cable. The test results can be compared to the category or rating of the cable to determine if the cable meets or exceeds the requirements. Tone generators and probes. These are devices that help locate and identify a specific cable among many cables in a bundle or a patch panel. Tone generators generate an audible tone that is injected into one end of the cable, while probes detect the tone at the other end of the cable using an inductive sensor. The probe emits a sound or a light when it finds the cable with the tone. TDRS. These are devices that use time domain reflectometry to determine the distance and location of faults or breaks in a cable. TDRS send a pulse of energy into one end of the cable and measure the time and amplitude of the reflected pulse at the same end. The reflected pulse can indicate if there is an open, a short, or an impedance mismatch in the cable. Topic 6. Cable documentation is the 6th and final subtopic in the 2nd topic of the book Data, Voice, and Data Video Cabling, 3rd edition. It covers how to document the cable installation using labels, diagrams, records, and reports. It also covers how to comply with the codes and standards that apply to VDV cabling systems. The cable documentation subtopic covers the following points. Labels. These are tags or stickers that are attached to the cables, connectors, jacks, patch panels, outlets, and devices to identify them and provide information about their type, category, length, location, and function. Labels should be clear, consistent, durable, and readable. Labels can be created using various methods such as handwritten, pre-printed, or computer-generated. Diagrams. These are drawings or charts that show the layout and configuration of the cable installation. Diagrams should be accurate, detailed, and up-to-date. Diagrams can include various elements, such as floor plans, cable routes, termination points, device connections, color codes, legends, and symbols. Diagrams can be created using various tools, such as paper and pencil, CAD software, or online applications. Records. These are documents or files that store the data and results of the cable installation. Records should be complete, reliable, and accessible. Records can include various types of information, such as customer details, project specifications, cost estimates, time estimates, material lists, test results, troubleshooting logs, and warranty terms. Records can be stored using various formats and media, such as paper copies, digital files, or cloud services. Reports. These are summaries or analyses of the cable installation that communicate the findings and recommendations to the customer or other stakeholders. Reports should be concise, informative, and professional. Reports can include various sections such as introduction, objectives, methods, results, conclusions, and recommendations. Reports can be presented using various modes and methods, such as oral presentations, written reports, or online submissions. Codes and standards. These are rules and guidelines that regulate the design, installation, testing, and maintenance of VDV cabling systems. Codes and standards should be followed to ensure safety, quality, and compatibility of the cable installation. Codes and standards can be issued by various authorities and organizations at different levels. Local codes such as municipal bylaws, national codes such as Canadian Electrical Code, international codes such as ISO IEC, industry standards such as TIAIA, or manufacturer standards such as Belden.